Welcome to section 7.2, which is the second half of our introduction to object-oriented programming and classes. In the second half of this section, we were introduced to constructors in the first half. This time we're going to learn about overloading constructors. We're also going to be learning about this thing called a destructor and how to implement it. Plus, we've been overloading functions all along. This time we're actually going to overload a series of operators. So we're going to overload in this lesson the plus symbol, the less than symbol, the pre and post increment operators, and then we're also going to overload the stream insertion and stream extraction operators, and these are specifically for use with class objects. And then finally, we're going to implement friend functions. All right, so here is a constructor, the default constructor, which you can tell it doesn't set my instance variables to anything. If I don't create a default constructor, my class automatically implicitly runs one when an object is constructed. So this is what it would look like if I instantiated an object of a teacher class. Now we can also overload constructors just like we can overload any of the other functions. And here's an example using an initializer list. So the first one is going to instantiate teacher with some default values with a name and a pay grade. The second overloaded constructor is going to overload it with some user provided values, once again using an initializer list. And this is what it might look like to instantiate an object with those overloaded constructors. So we're going to have a Peterson object, and then we're going to have a Valle object where we're going to give it some default values for the instance variables. All right, so this is an example of a destructor. The destructor looks a lot like a constructor a little bit. It has the exact same name as the class, but now it has a tilde on front of it. It requires no parameters and it returns no value. It is automatically invoked whenever an object is going to be destroyed. That means when an object goes out of scope from wherever it was created, either in the entire main section or in the entire main class or in functions within a class. So they don't have parameters or return values. They cannot be overloaded. There is only one destructor in a class, and it's automatically called just like a constructor is automatically called. So how about if we put this into some scope or some context with a distance class? We're going to create a distance class. It's going to distance seem to have a feet and inches, right? And so we're going to have a couple of constructors, and then we're also going to add a destructor to our distance class. We're also going to add a few other functions in here. We're going to display a distance, and then we're going to have a couple of getters that allow us to get the feet and the inches. All right, so what about overloading operators? This is the format for what it would look like to overload operators. There's going to be, it is a function, so there is some kind of a return type. We're going to use the keyword operator, then we're going to use the symbol of the operator that we are attempting to overload, and then perhaps a parameter list depending upon what we're trying to overload. So here are some examples. I give you 6 examples of what it can look like to try to overload operators. So the first one is where we're going to overload an increment, and so we're going to have we're going to increment an object. Number 2, we're going to add objects together. We're going to overload the plus sign to add 2 teachers. Number 3, we're going to overload the minus sign in order to subtract 2 distances. If you'll notice, the return data type is a distance, and the parameter includes a distance object. On number 4, we are going to overload the dual equal signs in order to compare 2 vehicle objects, and the bool return value is whether or not they are the same. Number 5, we are going to add an integer to a vehicle, whatever that means. We're going to have to decide what that might mean. And then number 6, we're actually going to overload the typecast operator, so to see if we can convert an object to a floating point. So this is what it might look like if once I had all those functions defined, if I was to actually implement those. So number 1, I'm just going to use the plus symbol on an object. Number 2, I'm just going to add the plus sign between 2 teacher objects. Number 3, we're going to use the minus sign between a couple of distance objects. We're going to use the dual equal signs to compare a couple of vehicles. And 4, on number 5, we are trying to add some kind of an int value to a vehicle object. And then if you'll notice, the number 6, I'm taking an object and I'm trying to implicitly typecast it into a float variable. So let's add a couple of functions to our distance class that will allow us to overload some operators. So the next thing that we want to do is overload the input and output stream. So this is an example of what it would look like to overload the output stream, or the O stream. We need the output type, which is a pointer to the O stream. We need the keyword operator along with the cout symbols. And then the parameter list includes not only an output stream, which we're going to call out, but some kind of a class object as well. It looks remarkably similar if we're going to overload the input stream. The only difference is now we're dealing with the I stream. In our parameter list, we're going to call our I stream in. We still have the same class object. So this is what it might look like if I was overloading 1 and 2. We're overloading the output stream, or the cout. Notice the only difference between 1 and 2 is the second parameter. We're going to output a teacher object, or we're going to output a vehicle object. Numbers 3 and 4 is where we input, overload the input, or the CN, and the second parameter is we're going to input a teacher object or a vehicle object. And this is what it would look like in a program using the traditional cout and CN. So how about if we add a couple of overloads to our distance class, the cout and the CN. Now you're going to notice that these are friend functions. So the IOStream operators have to be overloaded as a global function. But if we want to allow them access to the private members of a class, for instance, feet and inches, private members of our distance class, we have to make them friends. And so I'm going to start that with the keyword friend. The function is going to be declared inside of the class, but it is going to be defined outside of the class. And even though it is declared inside and defined outside, it is not a member of the class. So we will try this as a friend function. All right, so how about if we try it out? We're going to write our distance class, and we're going to